This video will cover SmartMesh, a patented Ruckus wireless technology. SmartMesh, at its essence, creates a self-healing multi-hop plug-and-play wireless network to help extend wireless coverage without Ethernet cabling. Before starting the course, please read and understand the copyright and proprietary notice on this page. The information contained in this course is confidential to Ruckus Wireless. This course is for informational purposes only. In this video, we'll cover an overview of the Ruckus SmartMesh functionality, describe a SmartMesh architectural network topology, define SmartMesh access point role selection, define SmartMesh path selection, describe consensus protocol, discuss zero-touch mesh, and list stability and performance mechanisms. Here are common terms and abbreviations that will be used in this SmartMesh training. RAP, which stands for Root Access Point, is the basic building block of a SmartMesh network. It is the access point which has an Ethernet wired network connection. All network traffic, ingress and egress, is forwarded through the root AP. The MAP, or Mesh AP, extends the wireless network without the need for cabling. A Mesh AP can be thought of as a wireless repeater. EMAP stands for Extended Mesh AP. It is a mesh node that is connected to its uplink AP through a wired Ethernet cable on a separate LAN, rather than wirelessly. EMAP nodes are used to bridge wireless LAN segments together. A mesh tree. Each mesh AP can have exactly one uplink to a root AP or another mesh AP, and each root AP or mesh AP can have multiple mesh APs connected to it, resulting in a tree-like topology. A hop is the number of wireless mesh links that a data packet takes from one mesh AP to the root AP. For example, if the root AP is the uplink to mesh AP1, then mesh AP1 is one hop away from the root AP. In the same scenario, if mesh AP1 is the uplink of mesh AP2, then mesh AP2 is 2 hops away from the root AP. A maximum of 8 hops is supported. BeamFlex Plus is a Ruckus patented implementation of dynamic adaptive antennas that are used to help shape the RF patterns to maximize the throughput on a per-packet per-client basis. Full duplex is communication in both directions simultaneously. Half duplex is communication in one direction at a time. ARPing is a computer software tool that is used to discover hosts on a computer network. The networking software tests where a given IP address is in use on the local network and can get additional information about the device using that network address. Ruckus SmartMesh networking technology makes mesh networks enterprise-grade. Instead of navigating complex configurations for each AP, all you have to do is just check a box in the user interface and the mesh forms automatically. SmartMesh reduces cumbersome RF planning and costly cabling by lowering the need to run Ethernet wiring to individual Ruckus APs. The benefits of SmartMesh include dynamically lowering development costs. The installer does not require any specific RF expertise. SmartMesh extends the range by minimizing the hop count. This ensures the highest performance. Ruckus supports a hybrid mesh architecture, which expands the mesh without reducing the throughput. SmartMesh deploys in half the time of a conventional 802.11 wireless LAN. SmartMesh has fully integrated interface avoidance, which ensures high reliability of the wireless LAN. It is automated, which keeps things simple, and finally, SmartMesh is highly secure. We have a best practice design guide for designing and deploying SmartMesh networks. Let's review the basics of how SmartMesh works. Here we see a root AP connected with an Ethernet cable to a Layer 2 network. The Layer 2 network has a Smart Zone OS5 controller. Meshing APs constantly advertise the potential throughput. Here, the first meshing AP advertises a capacity of 300 megabits per second. The second meshing AP has a direct view of the root AP. It may also advertise a capacity of 300 megabits per second. The third meshing AP, however, does not have a direct view of the root AP. As a result of taking an extra hop, 2 in this case, its capacity advertisement is 200 megabits per second. Wireless clients associate with the meshing APs. BeamFlex manages the best signal path to the clients inside the mesh. BeamFlex is also used to manage the best signal paths within the meshing topology. If a mesh node fails, SmartMesh self-heals. Let's review some of SmartMesh features. First, autonomous network mesh formations can occur over the wired or wireless link. No user intervention is required. The user may constrain the mesh network topology if desired. Multi-channel mesh paths are supported using wired mesh links or using EMAPs. A second feature is that SmartMesh self-heals. It optimizes the topology dynamically. This increases the robustness and performance of the SmartMesh network. The third feature of SmartMesh is loop detection and loop avoidance. SmartMesh quickly breaks loose should anomalies occur. This ensures 100% loop-free operation. The fourth feature of the SmartMesh is that SmartMesh leverages channel-fly in beamflex. SmartMesh also optimizes broadcast. This further improves the reliability of the mesh and enhances the performance. Broadcast reduction helps SmartMesh in Layer 2 deployments. The fifth feature of SmartMesh is that traffic like ARPing and other management frames are prioritized. This increases the robustness during traffic storms and during periods of network congestion. The sixth feature of SmartMesh is that management traffic associated with event logging, speedflex, link RSSI, topology reporting, neighbor history, and support status are forwarded within the SmartMesh. This reporting improves network management, network operations, and helps with troubleshooting. A final feature of SmartMesh is AP survivability and recovery SSID. Should a mesh AP find itself stranded with no path back to the root AP, Recovery SSID is advertised. This enables an operator to have remote access to the AP for troubleshooting purposes. Let's review the SmartMesh AP roles and how SmartMesh maintains trees to avoid loops. Here we see a very robust mesh topology. We have two root APs, which doubles the mesh capacity and also provides a level of redundancy and resiliency. We see 5 pairs of non-root APs. The non-root APs are connected with an Ethernet connection. After resolving the consensus protocol, one AP on the remote LAN becomes the mesh AP and the other AP becomes the EMAP or extended mesh AP. Two root APs are operating on different channels. As a result, there are 2 clusters of meshing APs operating on different channels. Meshing APs and extended mesh APs make path forwarding decisions which can occur over the wireless network or over the wired network, meaning that a meshing AP, take for example the AP labeled M connected to root 1 AP. That meshing AP may decide to forward traffic over the wireless interface to root AP1, but if topology or conditions change, that meshing AP may decide to forward traffic over the EMAP or over the green AP labeled as K. Should the connection to a root AP change or go down, the root AP will take on the role of the meshing AP. The mesh network topology will reform. Keep in mind that meshing APs and extended meshing APs may forward traffic over the wired link as well as the wireless link, and that meshing APs and EMAPs can operate on different channels. Let's review the role on different meshing APs. Let's also review how SmartMesh maintains trees to avoid loops. Here we see a topology of a very robust, redundant, and high-capacity mesh network. We have 2 root APs, R1 and R2. R1 and R2 are operating on different channels. We have 5 pairs of non-root APs. These non-root APs are connected with an Ethernet connection. After exercising the consensus protocol, one AP resumes the role of the meshing AP, while the other AP resumes the role of the EMAP. Mesh APs and EMAP APs may operate on different channels. Mesh APs and EMAP APs may make path forwarding decisions. Mesh APs and EMAP APs may decide to forward traffic over a wireless interface or over a wired interface. In summary, keep in mind that EMAPs and MAPs can forward traffic on a wired connection or over a wireless connection, in that MAPs and EMAPs can operate on different channels. Let's review the SmartMesh architecture. SmartMesh is comprised of 3 primary algorithms that run on the AP autonomously. Role selection algorithm. The role selection algorithm determines if the AP is running as a wrap or a map. Uplink selection algorithm. The uplink selection algorithm determines the topology of the mesh. The consensus protocol resolves the role of a map versus an EMAP. Let's review the elements of Layer 2 forwarding. Each AP implements a virtual AP function, which means that the single interface can operate as a station or as an AP, is bridging software between the station in the AP. In essence, a mesh path is a chain of AP to station connections, with the software bridge between the station and the AP. The mesh uses WDS for address mode to preserve the original source and destination addresses by referring to Layer 2 addresses. The mesh uses standard ARPing and standard bridge MAC addresses for learning and node discovery, and for making forwarding decisions. SmartMesh uses standard WPA AES encryption, node discovery, and RSSI sampling via active probe request and response is used for evaluating each path. 802.11h is used for coordinating channel changes.